Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integrals using the concept of beta functions, right? So in this lecture we are going to find out the value of this integral using the concept of beta function, right? So here we have to evaluate the integral 0 to 4 and the integrand is x raised to 4 times square root of 16 minus x square, right? So let us call this integral as I, right? So let us start. So viewers, what we will do here, we'll make use of the method of substitution, right? So first we'll write this integral as 0 to 4 x raised to 4 and we'll take this 16 common like this, that is 16 1 minus x square over 16, right? And then we can take the square root of 16 and the square root of 16 is 4. We can take 4 outside the integral sign, right? So we have 0 to 4 x raised to 4 and here we have square root of 1 minus x square over 16, right? Okay, so now we'll make use of the method of substitution and we'll take y is equal to x square over 16, right? So we'll introduce a variable that is y, which is equal to x square over 16. So now we can write x square is equal to 16 y, and we can also write x is equal to 4 times square root of y, right? So taking the square root of 16y, we have 4 times square root of y, right? Okay, now let us differentiate both sides with respect to y. So we have dx over dy is equal to 4 times the derivative of square root of y with respect to y, right? So this is 4 times the square, the derivative of square root of y is 1 over 2 times square root of y, right? So this is 2 to the 4, so we have 2 over square root of y, right? So now we have dx over dy is equal to 2 over square root of y. So now we can write dx is equal to 2 over square root of y and dy, or in other words we can also write it like this, 2 times y raised to minus half, and here we have dy, right? So for this dx we have 2 times y raised to minus half dy. So now let us change the limits. So here we have x is equal to 0 and the upper limit is 4. So when x is equal to 0, then we can find out the value of y from this relation. So y is 0 square over 16, that is 0. And when x is 4, we have y is equal to 4 square over 16, that is 16 over 16, that is equal to 1, right? So when x goes from 0 to 4, y goes from 0 to 1. So now we can write this integral in terms of y, right? So we have 4, then we have 0 to 1 and x raised to 4, right? See, x square is 16y. So we have x raised to 4 is equal to x square raised to power 2 and x square is 16y, right? And here we have square. So here we can write 16y raised to the power 2, and here we have square root of 1 minus x square over 16, that is equal to y. So here we have y. For dx we can write 2 times y raised to minus half, and here we have dy, right? Okay, now see, here we have 16 square. So 16 square is 256. So we can write 256 outside the integral sign, and we can also take this 2 outside the integral, and now we have 0 to 1, and here we have y square. This is y square, and here we have y raised to minus half. So here we have half, and then square root of 1 minus y can be written as 1 minus y raised to half, and here we have dy, right? So now the product of these three numbers is equal to 2048, and we have 0 to 1, and this is y raised to 2 to the 4, 4 minus 1, 3, so we have 3 by 2, and 1 minus y raised to half, right? Okay, now we'll write it like this: 0 to 2048, then we have 0 to 1, and see, y raised to 3 by 2. Now we can express 3 by 2 as 5 by 2 minus 1, right? So why we are writing this like 5 by 2 minus 1? In order to convert this integral into the beta integral, right? And here we have 1 minus y raised to 3 by 2 minus 1, right? So now we have written y raised to 3 by 2 as y raised to 5 by 2 minus 1, and half as 3 by 2 minus 1. So now see, the beta function is defined like this: beta mn, we can write it as 0 to 1, and here we have x raised to m minus 1, and 1 minus x raised to n minus 1 dx, right? So where m and n are greater than 0, right? So the Euler's first integral is defined like this: the beta mn is 0 to 1 x raised to m minus 1, and 1 minus x raised to n minus 1. So if we compare this integral with this one, then we can see that the variable is y here, the variable is x here, and it is not going to change it. And here m is 5 by 2 and n is 3 by 2, right? So comparing, we have m is equal to 5 by 2 and n is equal to 3 by 2, right? So now this integral I can be written as 2048, and here we have beta mn. M is 5 by 2 and n is 3 by 2, right? So now we have to calculate the value of beta 5 by 2 comma 3 by 2, right? And we know this relation, that is relation between beta function and gamma function, that is beta mn is given by gamma of m multiplied gamma of n and divided by gamma of m plus n, right? So the beta of 5 by 2, 3 by 2 is equal to gamma 5 by 2, then we have gamma here 3 by 2, and then we have gamma of 5 by 2 plus 3 by 2, right? Now see, in the denominator we have gamma of 5 by 2 plus 3 by 2, right? So this is 5 plus 3, 8 over 2, that is gamma of 4, and gamma of 4 can be written as 3 factorial, right? Because we know that gamma n plus 1 is equal to n factorial, where n belongs to some positive integer, right? So here we have 3 factorial. 3 factorial is 3 times 2 times 1, that is equal to 6, right? Okay, now to get the value of gamma of 5 by 2 and gamma 3 by 2, we'll make use of one important relation, that is gamma of n plus 1 can also be written as n times gamma of n, right? So gamma of 5 by 2 can be written as 3 by 2 times half times gamma of half, right? due to this result. So we have 3 by 4, and gamma half is square root of pi, right? So the value of gamma half is square root of pi, and gamma of 3 by 2 can be written as half times gamma of half, and that is half times square root of pi, right? So viewers, the value of this quantity is now 3 by 4 square root of pi, and here we have half square root of pi, and in the denominator we have 6, that is 3 factorial, that is 6, right? So this is 3 divided by 4 times 2 times 6, and here we have square root of pi times square root of pi, that is pi. So this is 3 to the 6, so we have 4 times 2 times 2, that is pi over 16, right? So now the value of this integral I is equal to 2048 times beta of 5 by 2, 3 by 2, and this is 2048 times pi over 16, right? So the value of this quantity is pi over 16. Now if we divide 2048 by 16, we'll get 128, right? So we have 128 times pi, right? So the value of this integral using the concept of beta function and gamma function is 128 times pi, right?